This short e-learning video will demonstrate how to use the example-based feature extraction tool found within ENVI to identify and extract rooftops from a multispectral image. This QuickBird image is courtesy of Digital Globe and has been provided for educational purposes. ENVI feature extraction is the combined process of segmenting an image into regions of pixels, computing attributes for each region to create objects, and then classifying the objects based on those attributes to extract features. The workflow is designed to be helpful and intuitive while allowing you to customize it to your specific application. For a much more detailed explanation and background on feature extraction and how it applies to ENVI, please visit the ENVI Documentation Center. We begin our process with ENVI loaded and the Digital Globe image in our main display window. Once the imagery is displayed, we must open the example-based feature extraction tool found in the feature extraction folder in the ENVI toolbox. The raster file is the primary image from which features will be extracted. For the ancillary data, you could combine a LiDAR digital surface model, DSM, with a base image to identify rooftops in a residential area. Furthermore, you could apply a mask at this point in the workflow and make sure ENVI ignores pixels that are unimportant to your analysis. We will be leaving all of the default parameters and moving to the segmentation portion of feature extraction. Segmentation is the process of partitioning an image into segments by grouping neighboring pixels with similar feature values, brightness, texture, color, etc. These segments ideally correspond to real-world objects. The segment and merge values you utilize in the workflow will be determined wholly by the features you are attempting to extract, as well as the quality of the data. Choosing a high scale level causes fewer segments to be defined, and choosing a low scale level causes more segments to be defined. Using the preview portal, we can view the effects of altering our segment and merge values in a dynamic fashion. You should ideally choose the highest scale level that delineates the boundaries of features as well as possible. Good segmentation ensures that classification results are more accurate. If you choose too high of a scale level, the boundaries between segments will not be properly delineated and you will lose features of interest. We settle on a scale value of 40 and a merge value of 15. We have chosen relatively low values for segmentation because of the fact that we are working in a residential area. Oftentimes, homes will have several levels, so the roof can be segmented into multiple objects. Keeping low scale and merge values ensures that objects will not be merged unnecessarily. With proper segment and merge settings applied, we are ready to start selecting objects as examples of certain types of features. We will only need to create a few classes and select a small number of examples in order to extract the rooftops from this scene. The region means image is a raster file that shows the result of the segmentation process. Each segment is assigned the mean band values of all the pixels that belong to that region. You should be able to see that the rooftops have been segmented quite well, as with the roads and some of the vegetation. The example-based feature extraction allows the user to hover their cursor over a segmented object, and select that object as an example of a certain feature. The cyan coloring you see filling in the objects as you move your cursor throughout the image indicates that you could select that object as an example for the specific class you have highlighted. After choosing several objects for the roads, several objects for vegetation, and many for rooftops, we can use the preview portal to get an idea of how well we have delineated between the residential rooftops and everything else in the scene. Through the use of the portal and the transparency slider, you can investigate how well the rooftops have been extracted. It appears as though some of the rooftops are unclassified, so we can simply hover over these unclassified objects and select them as rooftop examples. As a note, since we are only concerned with extracting rooftops, the vegetation class is clearly a misnomer. This class contains many different types of features, not just vegetation. You can spend a significant amount of time polishing your results, and if you have time, then experiment with how changing the extraction algorithm impacts your extraction results. Once we are satisfied with our results, then we move on to the export step. The FX workflow allows the user to easily export a shapefile, which contains all of the extracted objects and their associated class, as well as a classification raster image, and a statistics file that will tell you exactly how many pixels were classified as a certain feature. You can also quickly view the area contained in each class in square feet, square meters, miles, etc. After exporting the shapefile to the ENVI desktop, you could easily add the product to a geodatabase or push the product directly to ArcMap. The feature extraction workflow is highly powerful, and this was just the example-based approach. The rule-based approach allows for even more fine-tuned tweaking on the objects you will be extracting.